There are two ways to calculate the maximum kinetic energy of a pendulum. You can get there from maximum velocity, or you can get there from gravitational potential energy. Let's look at maximum velocity first. The kinetic energy is maximum when the velocity is maximum, which for an object in simple harmonic motion is at equilibrium. Using the velocity formula from your formula booklet, we set displacement to 0 and simplify. Once you have the maximum velocity, you can just use the usual kinetic energy formula. If this is maximum, this is maximum. If you cannot work out the maximum velocity, you will need to find the maximum gravitational potential energy instead. Potential energy is maximum at amplitude position, and so it's equal to mgh, where h is the height shown in the diagram, at amplitude the height of the bob above equilibrium. Assuming no friction of any kind, all this energy will be turned into kinetic energy when the bob reaches equilibrium, so this also equals the maximum kinetic energy. So to summarise, if you can work out the maximum velocity, you can use this to work out the maximum kinetic energy. You could then work out the height of the bob at amplitude. If they instead tell you h, you have to go the other way round. You can then use a half mv squared to find the maximum velocity. A really nice question would be the equivalent for an oscillating mass spring system. Here, instead of mgh for the potential energy, what would you use instead? As we know, the potential energy stored in a deformed spring is a half kx squared, so at amplitude that would be a half ka squared.